Lesson. Write the equation of a rational function in linear factored form from a graph. The important graphs are the ones where some things are not connected to some other things. When the unenlightened ones try to be profound, they draw endless verbal comparisons between this topic and that topic, which is like this, which is like that, until their graph is fully connected and also totally useless. Eliezer Yudkowsky. Important facts about rational functions. 1. If a function does not change the sign in the vicinity of a zero, root, then the zero has an even multiplicity. If a function changes the sign in the vicinity of a zero, root, then the root has an odd multiplicity. If x equals k is an equation of a vertical asymptote, then k is a root of the denominator. If k is also a root of the numerator, then its multiplicity in the numerator must be less than its multiplicity in the denominator. If the graph has a hole at x equals k, then k is a root of both the numerator and the denominator. The multiplicity of the root in the numerator is greater or equal to the multiplicity of the root in the denominator. If the graph has a horizontal asymptote, then the degree of the numerator is less or equal to the degree of the denominator. If y equals 0 is a horizontal asymptote, then to find the constant that multiplies the rational function, we must identify a point on the graph with integer coordinates. If y equals k is a horizontal asymptote, where k does not equal 0, then to find the constant that multiplies the rational function, we can use a point on the graph with integer coordinates, or use the ratio of the leading coefficients. Write an equation in linear product form for the rational function sketched. Question 1. This is the rational function that's sketched right in front of us. Let's start by identifying the key characteristics of the graph shown below. First, intercepts. We can see an x-intercept at point of coordinates 3, 0. 3 is a 0 of the numerator because of that. And the function changes the signs from positive to negative in the vicinity of 3. Thus, 3 has an odd multiplicity. X minus 3 is a factor of the numerator. F of x equals, and at the numerator we have a times the quantity x minus 3, where a is another possible factor of the numerator. Next, asymptotes. First, vertical. We have one at x equals negative 1 and x equals 4. Thus, negative 1 and 4 are zeros of the denominator. The function changes the signs from negative to positive in the vicinity of negative 1. Thus, negative 1 has an odd multiplicity. X plus 1 is a factor of the denominator. The function changes signs from negative to positive in the vicinity of 4. Thus, 4 has an odd multiplicity. Thus, x minus 4 is a factor of the denominator. B. Horizontal. Y equals 0. Thus, the degree of the numerator is less than the degree of the denominator. Thus, the numerator's other factor is a constant. To find the constant, let's choose a point on this graph. Point on the graph with integer coordinates. Point of coordinates 0, 3 is the y-intercept of the graph. Thus, f of 0 equals 3. Thus, a times the quantity 0 minus 3, everything over the quantity 0 plus 1 times the quantity 0 minus 4 equals 3. Equivalent to 3a over 4 equals 3, which is equivalent to a equals 4. F of x equals 4 times the quantity x minus 3 over the quantity x plus 1 times the quantity x minus 4. This equation checks all the characteristics of the graph. Question 2. Let's look at the key components of the graph of function f. X-intercept. At point of coordinates 3, 0. Thus, 3 is a root of the numerator. The function changes its signs from negative to positive in the vicinity of 3. Thus, 3 has an odd multiplicity. Thus, x minus 3 is a factor of the numerator. As a result, the numerator is a multiple of x minus 3. And we represent that by writing f of x equals, and at the numerator we write a times the quantity x minus 3. We have a whole at point of coordinates negative 3, 3. Thus, negative 3 is a root of both the numerator and the denominator. Thus, x plus 3 is a factor of both the numerator and the denominator. Asymptotes. We have one at x equals negative 2. Thus, negative 2 is a root of the denominator. And since the function changes signs from positive to negative in the vicinity of negative 2, thus, negative 2 has an odd multiplicity. Thus, x plus 2 is a factor of the denominator. The graph has a horizontal asymptote as well. There is not enough information to write the equation of the asymptote. However, we can conclude that the degree of the numerator is equal to the degree of the denominator. Thus, a is a constant. To find the value of the constant, let's choose a point on the graph with integer coordinates. Let's select this point of coordinates negative 7, 1. Thus, f of negative 7 equals 1. Thus, a times negative 10 times negative 4, everything over negative 4 times negative 5 equals 1. Simplifying this, we obtain 2a equals 1, which is equivalent to a equals 0.5. This is the equation of the rational function sketched below. When simplifying, the equation is equivalent to f of x equals the quantity x minus 3 times the quantity x plus 3, everything over 2 times the quantity x plus 3 times the quantity x plus 2. This function checks all the characteristics of this graph. Question 3. Let's look at the key components of this graph. X-intercept at point of coordinates 1, 0, which is a turning point on this graph. A function does not change the signs at a turning point. It remains negative around the vicinity of this turning point. The function is negative before 1 and after 1. Thus, 1 is a root of the numerator with an even multiplicity. Thus, x minus 1, everything squared, is a factor of the numerator. Thus, the numerator equals the product of the quantity x minus 1, everything squared, and another factor a. And we've represented that in our f of x equation. Next, vertical asymptotes. We have a vertical asymptote at x equals -1 and x equals 2. Thus, -1 and 2 are roots of the denominator. The function approaches negative infinity on both sides of the vertical asymptote x equals -1. Thus, the function does not change the signs in the vicinity of -1, and the function is negative on both sides of -1, which leads to the conclusion that -1 has an even multiplicity. Thus, the quantity x plus 1 everything squared is a factor of the denominator. The function approaches negative infinity on the left side of the vertical asymptote x equals 2 and positive infinity on the right side of the asymptote. Thus, the function changes signs in the vicinity of 2. The function is negative on the left side of 2 and positive on the right side of 2. Thus, 2 has an odd multiplicity. Thus, x minus 2 is a factor of the denominator. Point on the graph with integer coordinates. Let's choose the point of coordinates 0, -3. Thus, f of 0 equals -3. Thus, a times the quantity 0 minus 1 everything squared over the quantity 0 plus 1 everything squared times the quantity 0 minus 2 equals -3, which is equivalent to a over -2 equals -3, which evaluates to a equals 6. Horizontal asymptote. On the sketch of the function, it looks like y equals 0 is a horizontal asymptote. Indeed, the degree of the numerator equals 2, the degree of the denominator equals 3. Thus, as x approaches plus or minus infinity, y approaches 0. This is the rational function that checks all the key components of the sketch. F of x equals 6 times the quantity x minus 1 everything squared, everything over the quantity x plus 1 everything squared, times the quantity x minus 2. The end.